Hi there, welcome to MS Academica channel. Okay, in this video I'm going to present to you the answer and the solution and explanation for chemistry paper 4 062043 May-June 2020, and the time allocated for this paper is 1 hour and 50 minutes. Okay, let us go to the first question. Okay, for question 1, the structure of 5 organic compounds A, B, C, D, E are shown. Answer the questions that follows. Each letter may be used once, used more than once, or not at all. Okay, so we have A, B, C, D, E and 5 organic compounds over here. So now let me scroll a little bit down. Okay, now we have give the letter of the compound that is propane 1-ol. Okay, this is an alcohol. So alcohol, you have a functioning group of OH. Okay, functional group. So the OH here, this one is carboxylic, this one is alkane, this one is you have a double bonding over here, so it's an alkene, and we have a functioning group of carboxylic acid. So this is the acid, and here we have an acid, and this is the alcohol. Okay, this is the alcohol. So we have the functioning group of OH. So the letter is D. Okay, now move on. Okay, give the letter of the compound that has the empirical formula CH. So here they have a CH only. Okay, so there is no O. So not A, not D, not E, not so E, B, E is not your answer. So your answer will be either B or C. So if we take this C3 and H is 8, we cannot simplify this. Now we look at this C here. Okay, C here we have the C3 and H is 6. When we simplify this, because empirical formula means it's a simplified version. So here is C1 and H is 2 here. So we are getting this. So your answer is C. Give the letter of one compound that react with bromine in addition reaction. Okay, addition reactions is only occur to alkene. Okay, so your best choice for this is C, the same. Okay, so alkene here, it will undergo addition with bromine. So your answer here is C. Alright, give the letter of one compound that reacts with chlorine to form the compound shown. So we have okay, compound shown. Okay, this is with chlorine. Okay, with chlorine. So your best choice here will be boy. Okay, will be B, because alkane will undergo substitution reaction. Okay, so B. If you want to know the process, maybe I can add on over here. This is a substitution process that only happens to alkane. Okay, only happens to alkane with UV light, with the help of UV light. Okay, this is additional information. And give the letter of two compounds that can react with each another to form ester. So to form ester, we need a carboxylic acid and alcohol. So we need a carboxylic acid and alcohol. So it's either A or E and D. Okay, so we can put here D as the answer, D, and here you can answer A or E. Okay, it's either one. Okay, now here give the letter of the compound that is the same homologous series as hex 1N. So here should be the same group as this alkane, which is group C. Alright, over here. So your answer here will be C. And give the letter of one compound that is an acid. and acid is a carboxylic acid. They have this, okay, they have this functional group, so it's EO or A. So you can choose either one as your answer. So here you put A. Okay, we move on with next question. Okay, this question is asking, draw a structural isomer of component D, show all atom and all of the bonds. They give you 1 mark. So what is component D? Okay, the D here stands for propanol. So the OH is at the side here. So what we can do with the isomer is, so it's a propanol, so we can draw 3C here, and then we put the OH at this side, okay, in the middle, not at the side here. So if you even though you put the OH at this side, it will represent the D, okay, component D. So for the other C, we just attach with hydrogen, 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 and we are getting the 1 mark. Okay, so now some acid described as a weak acid. Okay, state the meaning of the term weak acid. Okay, so here weak stands for, okay, let me scroll down a bit. Okay, the weak here stands for it ionized partially, or you can see it's partially ionized. Alright, it's partially ionized. And the acid here, if you notice the acid, is a proton donor. Okay, acid is a proton donor. However, the base is a proton acceptor. Now I just want to give you a illustration of a strong and also the weak acid. So strong acid, let's say we have 10 molecules of a hydrochloric acid. Okay, so when it is dissolved in water, they will change into 10 hydrogen ion, and you have that 10 hydrochloric ion. So this is a fully ionized. Okay, this is a fully ionized. Weak acid, as example, like I choose this is ethanoic acid. Okay, so when I choose like 10 molecules, okay, 10 molecules, so when they dissolve in water, what happens is you might have only 5 which is ionized. Okay, so it becomes COO negative. You have these 5 ions, and you have 5 hydrogen ions. However, the another 5 will remain as a molecule. Okay, this one doesn't ionize. So when this happens, it is considered as weak. That's why it is a partially ionized. Alright, so we have completed the first question, and the marks given for the first question is 10 marks. Okay, now we move on with the second question. Okay, now we go to the second question. Okay, ammonia is manufactured by Haber process. The equation for the reaction is shown below here. Okay, state what is the mean by the symbol. Okay, this symbol is a reversible. Okay, your answer is a reversible. It means that your forward reaction is always equals to the reverse reaction. The reactant can form product. At the same time, the product can form to reactant back. Okay, they are reversible. So here, state one source of hydrogen used in the manufacture of ammonia. So in this case, your answer will be hydrocarbon reaction, or you can say hydrocarbon. Okay, hydrocarbon mainly used in this industry is a methane. Okay, it's a methane gas. Hydrocarbon with steam. okay, with steam. It mixes water. So this will produce a lot of syngas. Hydrogen gas is one of them. Okay, so this is the answer for this question. Okay, now we scroll down for question number B. Okay, B, the table shows some data for the production of ammonia. Okay, deduce the effect on the percentage yield of ammonia of increasing the pressure. Now let us observe the pressure here. So if the pressure increases, your percentage of the yield of ammonia will increase. Okay, now if you look at this part, when the temperature is constant, alright, so just focus on the 100 and the 400. So when the pressure is increased, your yield is also increases. So you can say increase in yield, or in a percentage yield of ammonia. Okay, it increase. I think the best way to write here, you just put the increases yield of ammonia. Okay, the word increases. Okay, now the second one is increasing the temperature. So when we are looking at temperature, let me erase this. Okay, when we are looking at temperature, your pressure has to be constant. So let us take these two. Okay, let us take this 250 and 250. When the pressure constant, now we observe the temperature. When I increase the 350 to 550, what happened to the percentage? It drops. Okay, so here you can say it decrease. Okay, it decreased the yield of ammonia. Okay, that's 2 marks for you. Okay, now let us carry on with the next question. Okay, explain in terms of particles what happened to the rate of this reaction when temperature is increased. Okay, here I will write the answer point by point. Okay, so the first point, when the temperature increase, the particles will have more kinetic energy, which is an increase in movement. Alright, so you can actually explain that further, increase in movement. And the second point here will be, you can say you have there has a greater collision. Okay, greater collision rate and high probability of so it should be off. Okay, high probability of particles having more energy than activation energy. Okay, you can say activation energy. So the last point here you have to say is there will be more collisions, more successful collision. Okay, there will be more successful collision which increase the rate of production. Okay, this is the answer for the 3 marks, and I will highlight for you the key points. Firstly is they have more kinetic energy, and second, you have a great collision rate and high probability of particles more energy than activation energy. You will have more successful collision, which increase the rate of production. Okay, this is how you explain in terms of particles. Okay, for a reaction to happen, you need firstly is the orientation of the atoms and also the activation energy. So we have to mention it all over here for 3 marks. Okay, we move on to the next question. Okay, now we come to D, 2D. Ammonia is used to produce nitric acid. Okay, this is the process called as the Oswald process. Okay, so Oswald process, this process is to manufacture nitric acid. Okay, this happens in a 3-stage process. Stage 1 is a redox reaction. Okay, identify what is oxidized in stage 1. Okay, what is oxidized in stage 1? So let us go through one by one here. So let us take, if we take oxygen, here the oxidation number here is 0. If you look at molecules or atom, they must have 0. Here is -1 and here is -2. So they are being reduced. So it's not for oxygen. Now if we take nitrogen, okay, nitrogen here, how we are going to check? So nitrogen will have 3 negative and here hydrogen is positive. So that's how they combine, they become NH3. Okay, so nitrogen is having -3 charge, and look at nitrogen here. Nitrogen, you have, okay, now let's say okay, we just take nitrogen. Okay, here this nitrogen, I'm not sure about the ion here. Now let us check with oxygen. Oxygen normally they have is 2 negative. Okay, they have 2 negative here. So if they become, there is no numbers here, right? You notice that there is no numbers down here. So it means that here it has been positive 2. Okay, 2 positive. So the nitrogen here is a positive 2. So it means it's higher. Alright, so it's higher. So it means it is being oxidized. So another way of to look at how it is oxidation happen, nitrogen has added it add oxygen, so it is oxidized. So substance oxidized here is N. Nitrogen, or you can put more specifically nitrogen in ammonia. So your reason here will be change in oxidation state, oxidation number from -3 to +2. Okay, that is your reason here. So you will be getting 2 marks here. Now let us look at the next question. In this reaction, the predicted yield is 512 gram. The actual yield is this. Calculate the percentage yield of nitrogen oxide in this reaction. So the percentage here will be 384 divided by 5512 multiplied with 100. Okay, let us check how much we get. Yeah, so you are getting there about 75%. Okay, you are getting there about 75%. So we have here 1 mark. You scroll down further. Okay, the equation of the reaction for the reaction in stage 2 is shown which major environmental problem does nitrogen dioxide cause if it is released into atmosphere? Okay, so what happened? What's the so here the issue here will be when nitrogen dioxide react with water. Okay, when react with water, or you can simply put there H2O, it produce nitric acid, which is this. Okay, nitric acids, or you can simply say it will form acid rain. So these are the one of the major environmental problem. So this is 1 mark here. We move on with next question. Okay, this is the next question here. Okay, the equation for the reaction in stage 3 is shown below. Okay, this is the equation. Calculate the volume of oxygen, okay, at room temperature and pressure. So this one is a 24 d metric cube, and please remember 1 d metric cube is equals to 1000 centimeter cube. Okay, so needed to produce 1260 gram of nitric acid. Calculate the moles of nitric acid. So here 1260 divided by the RMM. So the RMM for this is hydrogen is 1, nitrogen is 14, and your oxygen is one atom is 16 here, multiply with 3. Okay, so you'll be getting the 48. So our total here is you'll be getting the 63. Okay, you'll be getting the 63. So 1260 divided by 63, and here we will be getting the mole. You will be getting roughly 20. Okay, we have 20 moles of nitric acid. Okay, now they asking deduce the number of moles of oxygen. Okay, they want the oxygen. So here we have to play the ratio method where, okay, now let me circle, we write down in the blue color. This one you have 4. Okay, you have 4. Here's 1, here's 2, here's 4. We always follow the number in front. So this 4 we need 20 moles. Okay, so oxygens they need only 2 mole. No, this is water. Oxygen is 1 mole. So here will be divided by 4. So here we only need to have 5 moles here. So we just answer here is 5 mole. Okay. Okay, here to calculate the volume of oxygen gas. Okay, so we just use 5 mole multiply with 24. Okay, this is d metric cube, and you'll be getting the answer there, 120 d metric cube. So here's your 4 marks. Okay, so I hope you can understand this question, and let me explain this last question here. Okay, it shows the reaction in stage 3 is exothermic. It means it's releasing heat. Okay, so now this is the equation. Complete the energy level diagram for this reaction. Include an arrow that clearly shows energy change during the reaction. So if it is exothermic, it's releasing heat outside. So you should draw downward. Okay. So let me draw it more better. So a straight line that goes here at this part. Okay, so you can draw a dotted line over here. Okay, this is the energy that is released. Okay, so here you can draw the product. Alright, so here we are getting here for nitric acid, the product, and this is the energy release. Okay, this is the energy release. And this is the activation energy needed for the forward reaction, and this is the activation energy for the reverse reaction. Alright. Okay, so here once you draw this, you are able to get the 3 marks, and the total marks given for the question 2 is 18. Okay, next we move on to question number 3. Okay, number 3, chlorine is in a group 7 or 17 of the periodic table. 2 isotopes of chlorine is chlorine 35 or chlorine 37. State why these 2 isotopes of chlorine have the same chemical properties. Okay, chemical properties is actually referred to the group or their valence electron. Okay, group or their valence electron. Okay, since they given here 2 marks, you can actually explain that both of these isotopes, okay, both of these isotopes has same number of electron and same electron configuration. You can say configuration or you can say arrangement. So which is you have a 17 electron there, and we have electron configuration of 2.8.7. okay, so this is the additional information over here given. So it's 2 marks. So next we move to the next question. Okay, number 2, complete the table to show the number of electron, neutron, proton in each atom. Okay, so here we have this down here is 17, so which is proton number equals to electron number, and the difference between 35 and 17 is your neutron number. So here 35 we minus with 17, we are getting that 18. Okay, next if you look at here this part, the proton remains the same, which is 17, but this is ion. Okay, since it is ion, this atom is already received 1 electron extra, so you'll be getting that 2.8.8. okay, so here will be additional 1, which is 18. okay, your neutron number will be the difference between 37 minus with 17, the proton number. So here we'll be getting that 20. Okay, just be careful with the atom and the ion here, and you are getting here 3 marks. Okay, we move on with the next one. Okay, chlorine reacts with aqueous sodium bromine. State the type of reaction shown. Okay, this is basically a displacement. Alright, or you can write the single displacement, displacement reaction. Okay, why there is no reaction between iodine and aqueous sodium bromide? So if you look at group 17, we have fluorine, chlorine, bromine, and also iodine. So this is the most reactive. Okay, so your reactiveness is going down. So iodine is less reactive compared to bromine. So you can say your answer there, iodine Okay, so this is your answer. Iodine is less reactive than bromine, as I have explained over here. So you'll be getting there 1 mark. Here's 1 mark. Okay, next we move on with the next question. Okay, here we have a magnesium react with chlorine to form magnesium chloride. Okay, so here will be magnesium 2 positive and chloride 1. Okay, so we just write here 2 positive and here's negative. Okay, chlorine has a 2.8.8. Suppose it's 7, but it's already they receive 1 electron extra over here, so we just follow the dot. So here they have 8 dots. Okay, they have here 8 dots. Okay, however, for magnesium, the original is 2.8.2. Since they have donated 2, so you only will have that 2.8. So the last one will be, you only have 8. Okay, 1, 2, 3, 4, 5, 6, 7, 8. So we have to follow the symbol here. So once you have done this, iron, and this one, you'll be getting the 3 marks. Okay, we just move on. Okay, question 3D here. Hydrogen chlorine react to form hydrogen chlorine chloride gas. This is the equation and is expanded here. Okay, there's some bond energy are shown in the table. Okay, now they're asking us to calculate the energy change for the reaction between hydrogen and chlorine. Alright, so I'm going to elaborate here further. Here they have to break the bondings, right? Okay, they have to break the bonding. When you want to break the bonding, you have to absorb the heat. So once you absorb, this one will become an endothermic. Is an endo. Okay, so hydrogen and hydrogen will have hydrogen and hydrogen is 436. Now we look at chlorine and chlorine. When they break the bonding, we need 243. Okay, so your calculation here, let me scroll a little bit up. Okay, so your calculation here, calculate the energy needed to break the bonds. So you can say 436, we add with 246, you'll be getting the 679. Okay, 679. Okay, if you look at the other side, this is forming. Okay, this is, you have to form the bonding. So when you want to form the bonding, you will release heat. Release heat here will be more to exothermic. So H, chlorine and also iodine, it requires the energy of 432. And remember, you have a 2 over here. You have to multiply with the 2. Okay, and you'll be getting the 864. So here we are going to copy down the solution and we write over here. So we have that 432 multiply with 2 and you'll be getting 864. And they are asking for the energy change. Okay, they are asking for the energy change for the reaction. So you should be breaking the bond. Okay, breaking the bond minus with the forming the bond. Or simply endothermic minus with exothermic. So here you'll be getting the 679 minus with 864. So you'll be getting here in negative terms. When I calculate, I am getting here negative 185 kilojoule per mole. Okay, this negative, it shows it is this reaction is a exothermic. Okay, it's exothermic. So you have a total of 13 marks for the question number 3. Okay, for question number 4, filtration and chlorination are two stages in water treatment. State the purpose of each stage. So filtration is usually to remove solids, okay, solids, waste from water. Okay, however, the chlorination, as this one is more to kill microorganisms, okay, kill microorganisms, or you can say some microbes. Okay, so this is the purpose of both process here, and we are getting here 2 marks. Okay, now let us look at the question B. Okay, a student use anhydrous, okay, this is a dry, okay, it means like no water added, copper 2 sulfate to test the presence of water. So when you have water, what happened? This Cu copper 2 positive ion, you will have a blue color in the presence of water. So what color change is seen if water is present? So they will change to from white to blue. Okay, this is like a salt. So all salt at the dry state, you have it in a white color. Okay, number 2, the purity of a sample of water can be accessed by measuring its boiling point. So how is the boiling point of water affected by impurities? So these impurities will absorb heat, okay, will absorb more heat. So eventually what happens is their boiling point will be higher. So you can say boiling point higher than 100 or greater than 100. So you can say that than 100 degrees Celsius. Like sea water, for example, their boiling point is 105. This is sea water's boiling point. Okay, this is 1 mark. Okay, now we move to the next question here. Okay, chromatography can be used to test the purity of the substance. The diagram shows the chromatogram of a colored substance. Okay, how does this chromatogram shows this substance is not pure? Because here this substance, let's say we have a substance down here, and let's say they are using alcohol or ethanol or water to make this process. So when they diffuse, if the substance have more elements there inside, more substance, they will be separated, because each substance have their different water diffusion level. All right, so you can say they have more spots. Okay, they have more than one spot. So these are the spots that I mentioned. Okay, so if you have like more than one spot, it means it is not a pure. Okay, now they mention draw a circle round the correct RF value for the spot labeled X. So how the calculation is being made is from the starting line to the solvent front. Okay, let's say we just make it here as a H, and then the X position here from the starting line. Okay, so here we just make it as a A. So your calculation here will be A over H. So it is impossible for it to get 1.2 at this part. So this is wrong. And as you can see, this X point is near to this solvent front line. So it should be more than half. Okay, so obviously this is wrong. So your best answer here is 0.8. Okay, now look at the last one, last question here. Okay, state how a colorless substance can be made visible on a chromatogram. So this one we can use a locating agent, or by using let me just cancel out this one, by using locating agent. Okay, so this is your 1 mark. So total for these questions here, question 4, we have a total of 8 marks here. Okay, now we go for question number 5a. Complete the table about solid, liquid and also gases. Particle separation. Okay, if you look at solid, they are vibrating closely. Okay, so here they will be touching together. So you just can say here they are touching. Okay, particle arrangement for liquid. Particle arrangement for liquid, they are random because they are moving, their movement of molecules, of particles inside the liquid is very random. Okay, type of motion of gas over here is also random because we cannot predict where they are moving. Alright, so once you have completed this table, you'll be having here 3 marks. Okay, now let us move to B. Okay, the graph shows change in temperature. As an example, a sample of a gas is cold. So they are asking us name the change of state. Okay, this one they are talking about the process. Okay, they are talking about the process. So when the gas, here's gas, okay, here will be gas plus with liquid. At this point it will be converted fully to liquid. So this is the condensation process will be. So here, okay, the last one, okay, last question for the question number 5. A bottle of a liquid perfume. So we have a liquid perfume. Here's the liquid. Is left open at the front of a room. After some time, the perfume is smelled at the back of the room. So first physical process that will be taking is from liquid they'll change to gas, and this part is the evaporation. Okay, is evaporation process. And then let's say here's a room, okay, and the liquid bottle is over here. So here will be full of this perfume. So here will be high concentration, okay, high concentration of these perfume particles, and here will be low concentration. So what happens? High concentration to low concentration, here will be a diffusion. Here is a diffusion process. So here will be having 2 marks over here. Total for this question is 6 marks. Okay, we move to the next question. Okay, for number 6, an endothermic reaction occurs when calcium nitrate is heated. Okay, now we have to balance the equation for this reaction. Okay, now as you can see here, we try to balance it first. We try and error. So nitrogen we have 2. Okay, we put here 2, and oxygen we have here. Okay, here total number of atoms of oxygen is 6, but here when you calculate, here you are getting here 4, here's 2, and here's 1. So at the product side here is more oxygens. So what happens here is we have to double up at this side. So let me erase the 2 here. Okay, so when I make this side as 2, okay, now we balance it. Calcium we have 2, We put here two atoms of calcium, 2 atoms of calcium. Now we look at nitrogen here. Now we have here 2, multiply with 2, so here we got 4. So oxygen is 2. Total oxygen here we have 8. So if you look at here, we have 12 atoms of oxygen. So here we need to have another 2 more, right? 2 more. So it should be just 1. So it should be 2, 2, 4, 1 to get your 1 mark here. Okay. Type of reaction shown. When it is being heated, you can say it's a thermal decomposition. Okay, thermal decomposition is your answer for number 1. Okay, next is describe the test for nitrate ion. Okay, this is the test under an ion. So the first thing is you have to add aqueous sodium hydroxide. Okay, then the second step over here will be okay, after this you have to add aluminium foil. Okay, aluminium foil. So just remember both of these. So, and your results here will be ammonia gas will be produced. Okay, this is ammonia gas. Ammonia gas is being produced. So this one, you can say it turns litmus damp litmus paper red to blue. Okay, red to blue, because this is alkaline. This is more to alkaline. So we have here 3 marks here, and total for this question here we are having is 5 marks. Okay, we move to question number 7. Okay, we come to number 7 here. Okay, aluminium is extracted by electrolysis. Iron is extracted from its ore by reduction with carbon. Okay, what is meant by the term electrolysis? Electrolysis is we break down of a molten, okay, or you can say a breakdown of an electrolyte. And you can put a bracket here, can be either in a molten solution or is an aqueous. Okay. Okay, now we move to the next one here. Okay, name the main ore of aluminium. So this aluminium here is we call as a bauxite. Okay. C. Explain why aluminium cannot be extracted by reduction with carbon. Because aluminium, you can say aluminium is more reactive. Is more reactive than carbon. Because in an electrochemical series, aluminium is located above the carbon. So it is much more reactive than carbon. So that's why we cannot extract by reduction with carbon. Now we look at number 2. Describe the role of cryolate in extraction of aluminium by electrolysis. Okay. This is used in industry because the actual melting point of aluminium is 2100 degrees Celsius. So after putting the cryolate into the solution in the process, it went down to 950 degrees Celsius. Okay, so the purpose of cryolate is to reduce to read. Okay, to reduce melting point of aluminium oxide, or you can say to lower down the melting point of aluminium oxide. So that's the role of cryolid. Number 3, name the product formed at the positive electrode. Okay, the product formed at positive electrode, here we can do a revision here. Okay, aluminium oxide. So we have here aluminium ion, and we have oxygen ion. So at the positive electrode here, it will be, so you can see that here is a negative ion. It will be attracted to the positive, alright, positive electrode. So here what happens is, this anion will discharge themselves to become an oxygen atom, and they'll release 2 electrons here. So since oxygen appear as a Dewey atom, so here will be 2, we change this one to 4, and here will be 2. So the product forms is oxygen. Okay, so you can say it's oxygen gas. Okay, here write the ionic half equation for the reaction at negative electrode. So aluminium here will be attracted to the negative electrode, so they'll be receiving electrons and they will form solid aluminium. Okay, so this is the ionic half equation. So number D, aluminium is used in overhead electricity cables. Give 2 property of aluminium that it make it suitable for use in overhead electricity cable. So you can say because aluminium is light, okay, so you can say it's less denser, or you can say it is a low density. Okay, it is not heavy as like a copper or iron, and also it is a good conductor of electricity. Good conductor. So you have that 2 marks there. Okay, so now we move to the next question. Okay, iron is a transition element. Iron forms hydrated iron 3 oxide when it rusts. They want a word equation over here, so we just can put there iron, and for rusting of process we need water. We need water and also oxygen. Okay, we need water and also oxygen, and the product will be, you can see that copy this one, hydrated iron 3 oxide. Okay, this is a 2 marks over here. So number 2, give 2 ways in which the property of transition element differ from property of group 1. So you can say they are, so at the transition element here, it is much more higher density. Okay, higher density, because group 1 metals is a soft metals. Okay, so we can also say here is much more harder, and you can also include in other properties like it can act as a catalyst, or having a higher melting point, or form a colored compounds. Okay, these are the other options of this answer. So total for this question 7, you are getting here 14 marks. Okay, we move on to the last question. Okay, now is question number 8. Okay, a part of a synthetic polymer nylon is shown in the diagram. So the circle 1 amide linkage on the diagram. So it's a bit hard for me to show you the whole process over here. So let me use another whiteboard to show you the entire operation of this. Okay. Okay, now we have a amine group, and this H can be another carbon groups. Okay, and then we have a carboxylic acid groups, and you can see that here's R1 and here's R2. So when they are going to combine, they will produce the water. So what happens is they will take, so we have a hydrogen at this part, and then we have a OH. So we have a OH. Okay, so both of these, they will combine to form water. And the next process here, after they combine, you can see it will become R1, nitrogen and hydrogen, and they will combine with this. Okay, so you have carbon double bond with O, and you have the R2. Okay, we have a R2 to a. Okay, now you can see both of these will combine to form the waste. Okay, this is another product of this process, and this is the amide linkage. Okay, this is the amide linkage, and they will continue. So as you can see, there is a white box and a black box, right? So this is the white box and the black box as example. So we can use this. Okay, we can use this to answer the following question. So as we have learned just now, the amide linkage here will be this part. Okay, you can just circle this. Okay, so now the second question here will be complete the structure of the two monomers that react to form nylon. Okay, as you can see, this part, okay, is supposed to be OH, and here is supposed to be OH, right? So you just can put there double bond, C double bond, okay, like this, and then we have the OH, and we have here OH. Okay, this is a one monomer. Okay, if you look at this part now, okay, the combination here, you have another H at this part, at the both ends. So here we have N, H. There's a 2H there, and you can put on top or down. So we have completed these two monomers over here. So marks given is 2 marks here. Okay. Okay, for this question, name the other product formed when nylon is produced. So we can say is water. Okay, items made from the nylon are often disposed of by burying them in the ground. This is called landfill. Why is the disposal of nylon using landfill is a problem? Because nylon is a non-gradable substance. You can say it's a non-biodegradable substance. Okay, so this is your answer, non-biodegradable. This is the main problem of disposal of a nylon. Okay, so we are getting here 1 mark. Okay, give the name of a natural polymer. Natural polymer you can say as a protein or carbohydrate. Okay, so this is the organic. Alright, so we have completed this paper. And if you have any other questions, please comment below and I will do a video for you. Okay, so I hope you enjoy my video, and also I hope this video helped for your chemistry revision. Okay guys, all the best. Please subscribe to the channel and I will upload more videos soon. Thank you very much.